Hello, my name is James Traynor, Managing Director from ECD Archetypes. I'm going to be talking today about retrofit solutions for social housing archetypes as part of the SHRA Masterclass series. First, just a word about ECD. Myself, I'm Managing Director of ECD, which is Energy Conscious Design. We are a practice of architects and retrofit specialists based in London, Glasgow and Preston. And I'll skip forward to talk about our agenda today, which is to talk about deep retrofit, standard retrofit, there's different types of social housing archetypes, comparing those and what the benefits of going from standard to deep retrofit might be, lessons learned from previous retrofit projects, and then questions at the end. So to introduce our work, we've been involved in a variety of retrofit projects, from deep retrofit projects, which are such as Netherfield, which is the passive house retrofit standard from our projects at Wilmcote House, and Energisprong projects, which are also deep retrofit projects, and perhaps more mainstream projects, SHDF funded projects through the demonstrator and Wave 1 programs, and ECO and LAD funded projects. First, just to talk a little about the reasons for retrofit. Obviously, carbon reduction is a key issue. The energy performance of the average home is shown on the graph there in the middle of the screen, the orange bar, showing a space heating demand typically of about 140 kilowatt hours per square meter per year, and the performance reduction targets for the Wave 1 program were shown in the dotted blue line there as 90 kilowatt hours, so a significant reduction in the space heating demand, which will reduce carbon emissions. But to achieve a full net zero carbon enabled building, a home, we will need to go further than that, and some of the dotted lines further down the screen show what might need to be achieved by way of performance, and we could be looking at typically below 50 kilowatt hours ultimately. The human aspect of retrofit that is brought to the fore at the moment, given the increasing prices of energy, particularly in gas, and the impact on fuel poverty. And given that the vast majority of UK homes still use gas as their main source of heating, the need to tackle retrofit is ever more pressing. It's also a massive opportunity and a growth area. As you can see, that graph there shows the anticipated growth in the construction industry if the retrofit challenge was financially stimulated and enough funds were provided to meet the retrofit need. And you can see the necessary growth in the different parts of the construction industry, and you can see the retrofit coordinators, which is the design aspect of retrofit, shown at the top, the light green color there. So all aspects of the construction industry need to grow to deliver this and to enable us to decarbonize over the next 30 years. So now to talk a little bit about some social housing retrofit examples. This is a project we're currently working on for Kensington and Chelsea on the Lancaster West estate, which is the estate to which Grenfell Tower belongs. It involves several different housing types. We're involved in 4 different schemes on the estate, and approximately 220 homes. And on that list there, you can see the variety of different properties. So 1930s mansion blocks, 1950s deck access homes, 1970s walk-up blocks, and then 1980s houses, 2-story houses and 3-story flats. So a real variety of different social housing archetypes all on one estate. Lot 3, which is the Talbot Grove and Moorland House project, is part of the SHDF demonstrator program. So it's required to achieve a space heating demand of 50 kilowatt hours per square meter per year. It has solid wall masonry. It's the oldest of the blocks that we're involved in. It's not in a conservation area, although it has some architectural merit, and it's connected to an existing district heating system, which is also being refurbished as part of a separate project. It has, as with many blocks of that period, common walkways and narrow common walkways and no lifts, so it's walk-up blocks. And we were looking at all options, but all of them included a whole house retrofit solution. This graph shows the existing space heating demand was very high at the moment, much higher than the average homes in the UK. And we looked at various options to reduce that. You can see on the right-hand side the reduction in space heating demand. The red part of the bar is reducing from 325 down to less than 40 in the Netherfield scenario on the right-hand side. And both of the Netherfield and AECB standards, that's the Association of Energy Conscious Builders standards, will achieve the space heating demand of SHDF. So we're currently pursuing the AECB standard on that project. But first we had to understand whether we were tackling the project through external wall insulation or internal wall insulation. Given its solid wall properties, we needed to significantly reduce the space heating demand through the wall. But obviously internal wall insulation is hugely disruptive and would have required a full decant of all residents. It would have left a residual thermal bridging risk, and it would have, of course, reduced the flat sizes, which were already quite small. Relatively high ceiling heights in these blocks, but very small flat sizes, so not something we really wanted to do. On the right-hand side, you can see the external wall option. However, that would have resulted in a visual change to the exterior and required a planning application. And it would have, in this case, reduced the width of the communal stairs and walkways, assuming we didn't enclose the walkway, which is a question I'll come on to later for some of the other blocks. But you can see here that the impact on the staircase, which would remain external part of the building, unheated space, but reduced in size. We also looked at the window selection. The existing properties had sash windows, which were popular, but very leaky and single glazed. And in order to achieve the space heating demand reduction, we needed excellent thermal performance, but we also needed ease of use as a key consideration, and low maintenance and security, particularly at ground floor levels and deck access areas. So we looked at a whole range of different window types, as you can see on the right hand side there, and have settled on a mock sash window, which gives the aesthetic qualities that we need and also gives the security, but also the thermal performance critically that we need as well. Taking residents through the process and understanding it carefully and clearly what the retrofit journey would look like, the impact on their lives, is absolutely crucial. And this little series of diagrams was part of a consultation process that we undertook to show what the impact of the works and the sequencing of the works would look like. So beginning with the scaffolding, moving on to the roof works, doing internal ventilation works, MVHR, and then tackling the external envelope, the walls, then doing the windows and doors, and finally the photovoltaics on the roof, and then handover. So understanding with a program, breaking that program down into plain English and explaining the practical impact on residents was absolutely key. So the next project I'm going to talk about is also on the Lancaster West estate. It's Treadgold House, and it was part of the Energisprong projects, which require a performance guarantee by the contractor. And this image here shows CGI of what the building could look like post retrofit. The contractor is responsible for design and delivery, so it ultimately may change slightly, but that's the concept design. But it requires a wholesale, whole house, whole building retrofit solution, which equally is very demanding. You can see the existing building there, the significant heat loss through the walls. The flank walls are, or the walls with the balconies on are cavity wall, but you can see that there's still a significant amount of heat loss through those. And the gable end walls, which you can see on the right hand side there, the purple part of the wall, that is a solid wall at the end. So losing a huge amount of heat through the walls with extensive thermal bridging. You can see on these graphs what the existing performance is on the left hand side. The two bars on the left hand side there show the existing heating demand for the south and west wings of the building, the red parts of the bar there, and on the right hand side what we are looking to reduce them to on the south and west wings. You can see that because of the orientation it varies, and what the carbon reduction targets are on the bottom right. A key question for this block, which could have applied to the previous scheme as well, was to whether to enclose or not the walkways. And there are pros and cons to doing that. Enclosing the walkways makes the building simpler in a sense that you don't have thermal bridging as the building steps in and out. So the walkways are currently exposed. So if you can imagine you're losing heat through the floor and the roof and the wall on that walkway. So it would, in a sense, be simpler to enclose that walkway. Then you're only potentially losing heat from one route through the wall. However, in order to do that, that space needs to be properly ventilated, and it has implications on fire safety. So to do that, if it was enclosed, it would have required either 2 new stairs, which are shown on the left-hand side, the diagram on the left-hand side, or the middle option, option B, it would have required 2 new smoke shafts, which are the red bars shown there as well. Because the existing stair, which is in the knuckle, the joint of if you like, between the south and west wings, is not a protected stair and couldn't be made to be protected. So it either required 2 new protected stairs or 2 new smoke shafts if we were to enclose those walkways. The third option is to not enclose the walkways. However, you then need to think about the thermal bridging and how you're going to resolve all those potential heat loss areas, all the columns, all the walls, all the floors, and roofs and soffits, etc. So, and that little cross section there shows the complexities that we were dealing with, and the details shown at the ground, at the roof, and the walkways particularly are very tricky. You can see the red bars show the heat loss path in different locations and how we needed to tackle those. So this page looks at the options for that. A, B and C on the left hand side, options A, B and C in plan and section, showing whether we should insulate the walkway, the top of the walkway, and the underside to protect that concrete and reduce the heat path. But then that obviously had implications on the floor to ceiling height, and you can see that's been carefully measured to establish whether we've got a problem there. And you can see the column on the deck plan above also has to be insulated because we can't lose heat through that. That's also a source of heat loss. So you can see on the right hand side, overall, the insulation to the roof and to the left hand side of the building is relatively straightforward, but on the deck access side it can be quite difficult. But for the reasons explained, ultimately this is the selected option because it reduces the need for additional stairs or a smoke shaft. So now I'm going to talk about a scheme in Milton Keynes, which is part of the SHDF Wave 1 project. So a slightly less demanding space heating target. Part of the very first phase of Milton Keynes Newtown development, the Netherfield estate, it's actually a timber frame scheme of several hundred homes, and in a modernist language, as you can see there. But it's suffered quite badly over the years, deteriorated, and there is significant heat loss from all of these homes, and they have the same construction typology, but significantly different form factors, so different heat loss scenarios. So particularly the bungalows are but very, very bad in terms of heat loss. But the first thing to do was to identify all the different archetypes, and the plan on the right hand side, which I realise is quite hard to read, is just identifies whether they're 3-bed, 2-bed, 1-bed or flats, and the different scenarios. This just takes a section through a typical house and shows some of the issues that residents are facing in terms of mould and poor air quality, significant heat loss in different areas through the roof, the walls, the floor, and the windows, which are also quite poor. So it's largely unchanged and has significant issues, poor thermal performance and disrepair. So the intended outcomes, which need to be set at any retrofit project under PAS 2035, are shown on the right hand side there. All of those issues are relevant to the client. They need to meet the performance target, but they also need to reduce the energy demand, tackle the mould and condensation, and reduce emissions and improve fundamentally comfort of residents. So the worst performing property, as I say, was the bungalows. Bungalows often perform worse than other property types because they're relatively high wall to floor ratio, but these were particularly poor, these bungalows, because of the way they were planned out. They had a central courtyard in the plan, which made it even worse. So we tackled that first because we knew that if we using the same specification, if we could achieve the performance target for the bungalows, then we would be able to hit the demand for the other properties as well. So the starting point was 290 kilowatt hours, so incredibly high, and by the incremental measures shown on the right hand side there, we reduced the space heating demand down to the target of 90. So roof insulation, wall insulation, window improvements and air tightness and heat recovery. So that's the measures shown there, and you can see that it's the air tightness boundary is also shown, and insulation to the roof and walls. We also need to ensure that the existing architectural language is respected. So it's not a conservation area, it's not a listed property, although there is possibility that in future that might change, but at the moment it's not a conservation area. But we wanted to retain the modernist architectural language, and you can see some of the images there which show the design intent. Now I'm just going to talk about how the impact of the works on Netherfield estate could have what it actually has achieved in terms of space heating demand and carbon reduction, and how that could have gone further, both now and in the future, as part of a route to full decarbonisation. So the SHDF Wave 1 typically reduces carbon emissions by half, and the bill reduction, this is based on energy bills pre-October 2021, so before the recent spike in price rises, but you can see there that the energy bills are reduced significantly, not quite by half, but a significant reduction. But currently the gas heating will remain in the properties, but the home will be more comfortable. But if we had gone further, if we'd increased the thickness of the insulation, if we'd installed higher performance windows, if we installed mechanical ventilation or heat recovery system, thicker insulation to the walls, perhaps an air source heat pump replacing the gas boiler, what impact would that have had? And also the floor insulation as well, perhaps if the property was void, what impact would that have had on both fuel bills and carbon emissions? Well, you can see on the graph there on the right hand side that by reducing the space heating demand further, we have reduced the fuel bills, but perhaps not as much as you might expect, because we're switching now to electric, because electric is obviously more expensive than gas currently. Although it's it would be a heat pump, it's still going to be more expensive, the unit cost, than gas. So the cost will reduce, but not by a huge amount. But the carbon emissions will significantly reduce, and this is obviously a factor which we need to consider going forward. And of course, the relative price of gas and electricity may well change over time. So that's another factor which is worth considering. And finally, we're going to talk a little bit about lessons learned from retrofit programs, and this is reflections really from our perspective as architects and surveyors involved in multiple retrofit projects, large retrofit projects around the UK. And one of the challenges in any project is identifying the archetypes in a scheme. So and we define archetypes by the construction typology. So is it a traditional property or a non-traditional? Is it and there's multiple different types of non-traditional. Is it cavity? Is it filled or not filled? Is it timber frame? They are the archetypes. Is it a sub-archetype? So is it what is the location of that property? Is it an end terrace, a mid terrace, top floor, flat, etc.? All of those things will make a material difference to the heat loss of the property. And then finally, is it a variant? So has it changed significantly since original construction? Has it been extended? Has it been converted? All of those things will have an impact. And how many of these should we assume when considering a project? And once you understand all of your archetypes and sub-archetypes and variants to a certain extent, then it makes the much easier the process of retrofit, because you have a pattern book effectively that enables you then to apply that to the rest of your properties. But getting to that point can be quite challenging from a standing start, and the lack of information that landlords typically have means that we really have to start from scratch in many cases. Party walls are a key issue, and party floors, but party walls particularly can be a challenge. If the neighbour is perhaps a leaseholder or freeholder and they don't want to be or can't be part of the retrofit programme that you're undertaking, there is a potential heat loss through that party wall, as the red arrow shows there, and we need to model that to understand the risk of thermal bridging and condensation. We don't want an unintended consequence by insulating the outside of your wall, as shown on that middle picture there. We could exacerbate the problem. We could concentrate heat loss at the party wall and then potentially have condensation and mold, which previously wouldn't have occurred because the heat loss would have perhaps been or not to the same extent, because it would have been spread across the entire wall. So we need to model that if that is the situation, if it can't be insulated, and we need to understand if that is a risk. And if it is a risk, then we need to insulate internally, as shown on that plan. We might, in some cases, need to insulate the party wall on the inside of your property up to, in this case, the chimney breast, to reduce the heat path. In this case, we managed to model by a psi value calculation, which is the diagram shown on the right hand side, that under normal conditions, normal humidity and normal heating levels, it would not result in condensation and mold growth, and in this case we could proceed. But that needed to be carefully modelled, and we need to do that in every case, depending on the archetype and the location. So it's something we can't just proceed at risk, and we can't sign that off as retrofit coordinator until we're satisfied that that risk has been mitigated. Another lesson learned from large retrofit programs is the need for extended consultation, and which we completely and wholeheartedly agree with, because pre-2019 and pre-PAS 2035, many of the retrofit programs that were undertaken had very poor levels of resident engagement, and then as a result had poor outcomes. So resident engagement is absolutely key. Bringing residents on board, understanding what their concerns are, and showing how the works can address their concerns, and modifying the design in some cases to ensure that the design reflects what is needed by residents as much. It's not just a technical solution, it's tackling people's needs in their homes. So the retrofit advisor role is key, and that's now very much part of the retrofit process, and that can increase understanding, and many landlords are training people to be retrofit advisors within their RLO teams, and it's a key part of the process. And active co-design can improve the outcomes, but timescales for this should not be underestimated. So the images shown on the right hand side, that is from our scheme at Lancaster West estate, which obviously was best practice in terms of co-design, but has resulted in extended timescales for completion of the project. So these are all reflections on large retrofit programs that we've undertaken, and hopefully the session today has tackled some of the or identified some of the social housing archetypes that are out there. There are many other types that I could have talked about: high rise, individual homes, etc. But hopefully the session today has provided some useful guidance on some of the common problems that we face in retrofitting our homes. Thank you.